Homework 8.1 is one of the, in my opinions, easiest homeworks. I feel like I could have given this in a third grade class and they would do just fine. However, it's also one of the most frequently messed up homeworks, mostly because people don't follow directions, which is frustrating. So you need a stopwatch. You need to be able to measure yourself. You can do it using your phone or whatever. I don't super care, but you have to be able to measure something. And what you're doing is you're counting to different powers of 10. So first you're counting to 10 to the 0th power. 10 to the 0th power is 1. And so you're counting how long it takes you to count to 1. It should take you something like 0.1 seconds, like something very, very close to 0 seconds to count to 1. The next power of 10 you're counting to is 1, and 10 to the first power is 10. So you're counting to the first power of 10. So you're going to be counting to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't actually care how fast you count as long as you're consistent each time you count. So if you count fast going to 10, count fast on the next ones. Then you're going to count how long it takes you to count to 100. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You can count in your head, you can count out loud. I don't really care. But you do want to accurately measure how long it takes you to count to 100. And then you're counting to the third power of 10, which is 1,000. You're going to see how long it takes you. So I have not done this myself this year, but for most people it ends up taking like 0.2 seconds to count to 1. And that's mostly limited by how bad they are at stopwatches. It's probably a lot lower than that to count to 1. To count to 10, it takes most people about 1 second. To count to 100, it usually takes people about, different people take different amounts, but somewhere around 30 seconds. And usually, this is in seconds, so to count to 1,000, it usually takes people, something like 250 seconds, something like that. Now, obviously, your numbers may be very different from this, but that's what you're doing. So that's the bulk of your homework is spent counting, and then you're graphing your data on a chart, and this is the part that, inexplainably to me, people struggle with. In a graph, the x variable goes on the x-axis. In a table, the x variable goes on the left side. So this is the x variable. And so the x variable should be the time taken to count, measured in seconds. And the y variable is the various powers of 10 you're counting to. So power of 10 counted to. So obviously you need to scale your graph appropriately. The powers of 10, you only need to get up to 3, so you can go 1, 2, 3. To get up to 250, you probably need to count by like 50s or something. I see people struggling and trying to just put random things on the graph. Your scale has to count by the same thing each time. And so the reason I chose 50s here is because in my make-believe data, I needed to get up to 250, and I knew counting by 50s would get me there. You may need to count by something else to make sure you get high enough. But for my data, I've got 0.2, which is almost right here. I've got when x is 1, the y value is 1. That's right here. When x is 30, the y value is 2. That's right here. And when x is 250, the y value is 3. So your data might not look exactly like this. Again, partially because I just made up my data. But it should have this general shape. And what this should remind you a little bit of a square root graph. And so we will be talking about that soon and how it's different from a square root graph. Specifically, you could have negative powers of 10 that you counted to. For instance, 10 to the negative third power is 1/10,000th. And so maybe it takes you even less time to count to 1/10,000th, depending on how you're counting. So there are ways for it to end up looking kind of like this, where there's an asymptote. And we'll be talking about this tomorrow. So